Okay, well, let's go ahead and get started. A few details before we get right back into the lesson. The biggest one, of course, is next Friday the 7th. What's happening? Okay, that's going to be your second exam. We are going to be able to start trigonometric identities next week, but we are in no way going to be able to finish that before the test. So the test is going to be actually very similar to the quiz you just took. You're going to have to graph a trig function for me, but this time I put one of the other four. It'll be tangent, cotangent, secant, or cosecant, okay, on there. So you'll want to be looking at that. And then the rest of the material is going to be inverses of the trig functions, okay? I'm pretty confident that we should be able to finish this up tomorrow. I'll get you the homework assignment, and then we'll talk about when that's going to be due, and, we'll just keep moving along. Because at the end of next week, we're only going to have 2 weeks left, and really one of those weeks has to be district assessment review, and then we have our finals. So it's going to be happening pretty quick. Okay, Savion, let me go ahead and get that from you, sir. Thank you. All right, now that I have all the quizzes, who is Green Arrow's sidekick? It is Speedy. It is Speedy. That is correct in the comics and in the show. Yes. But Speedy has been both a male and a female. Okay. All right. The only other thing I want to go ahead and mention is that I've had some people go ahead and do this, but remember, Friday morning is the deadline if you're wanting to retake the first exam from before Thanksgiving break. I would really encourage a lot of people in here to go ahead and take advantage of that, seeing as how we're very close to the end of the semester. But you still have a couple of days left. Come on in if you have any questions. We'll get that taken care of. Okay, so let's get right back to inverses. Now, big picture here, or Zach, did you have a question? More than likely on Friday, my hope is that we go ahead and start talking about the other three inverse trig functions. Okay, so we should be able to finish this up tomorrow, and then we'll go ahead and start that then. Satish. Hopefully finishing up these notes. Yes. All right. So let's see, big picture, when we're talking about inverses, we want to take the x values and the y values and do what? We want to flip them. The x's become the y's and vice versa. Now, the pattern we've seen for these is pretty consistent. Based on whatever trig inverse you have, you're going to decide what quadrant it's in. Go ahead and create your triangle. If it's a special right triangle, we should be able to figure out the reference angle pretty easily. If it's not, that's when we're going to have to use our protractor. So very quickly, let's go ahead and take a look at 2 unit circles, because we have 2 inverse functions that we've looked at so far. Let's say sine inverse and cosine inverse. Okay. Now, what 2 quadrants will sine inverse be restricted to? Okay, 1 and 4. So we have to be looking on the right side of the unit circle, between negative pi over 2 and pi over 2. Now, sine inverse, we can include those endpoints. Okay, those answers are going to be able to have those as well. What about cosine inverse? Where's he restricted? He's restricted to 1 and 2, so he's the top half. All right, so all the answers you get out of cosine inverse have to be between 0 and pi. And again, you're noticing this on the limits that we have right here. And really, I should say intervals that we should have here. Now, how do we tell whether it's sine inverse or cosine inverse what quadrant we're going to draw the triangle in? Yeah, look to see if that ratio is positive or negative. Positive, of course, is quadrant 1. Negative would be the second or the fourth, depending on what inverse trig function you have. The only thing I want to go ahead and make sure to emphasize, if you're dealing with sine inverse and your triangle ends up in the 4th quadrant, remember, you've got to rotate clockwise, so your answer is going to be what? The answer is going to be negative. Now, the same thing, we saw this yesterday right at the end of class. If our cosine inverse, if your triangle happens to be in the 2nd quadrant, remember, the reference angle is going to help me out, but we always begin rotating from standard position in order to get there. Okay? All right. And the only other thing I could go ahead and bring up, how are we feeling with the special right triangles. Do we feel like we're pretty solid on those? Do we need to kind of go over them again, or what do you think? Take that as we're okay. All right, then I think we only have a couple of cosine inverse problems to take care of. All right, we finished up B, correct? Okay, so there's B. Let me go ahead and erase this. Let's move right along to C. Now remember, square root of 2 over 2, that represents a ratio. Whatever you're plugging into cosine inverse, just like sine inverse, it's a ratio of sides from a triangle. And they both have to be between the interval -1 and 1. Okay, and we just talked about where the answers are going to be. So if you plug a ratio into a inverse trig function, we're going to get the angle measure. So what quadrant would this be in? 1 or 2? Okay, Christian's saying 1. What do we base that off of? Yeah, the fact that square root of 2 over 2 is positive, right? Remember, cosine inverse has to be in 1 or 2, and because it's positive, I'm choosing 1. So we go ahead and draw my terminal side, just like I always do. Now we're going to connect that perpendicular to the x-axis. That creates my right triangle. So this angle here, the reference angle, that's what we're looking for. Okay, we always start to rotate on standard position. Well, what are the side ratios for cosine? It was what over what? Yeah, it was adjacent over hypotenuse. So the adjacent x over the hypotenuse r. So I know from this angle's perspective, we have square root of 2 here and 2 here. So is everybody okay with how I'm creating the triangle? So how can I figure out what the third side is? Yeah, we've been using the Pythagorean theorem. So I think this might be the only one today that we go ahead and run through with that. Y squared plus the square root of 2 squared is equal to 2 squared. And what happens when you square a square root? They cancel, so I just left with 2 is equal to 4, 2 squared. And I'm going to subtract the 2 over. Y squared is equal to 2, so y should be what? Okay, square root of 2. Is this a special right triangle? Yes. Okay, in fact, which one? 45, 45. How do we know? Yeah, what's the huge, huge indicator? These two legs are identical. If those two legs come out identical, this is a 45, 45, 90. So the theta that I'm looking for here is 45 degrees. Or if I wanted that in radians, what would that be? Pi over 4. Okay. And we could easily check that in the calculator. Does anybody actually want me to go ahead and plug it in to show you that we should be getting it? Stephanie, you want to see it? Okay. Now remember, whatever mode your calculator's in, that's the answer you're going to get. So right now mine's in degrees. So let's go on over here, cosine inverse. I'm going to go ahead and say the square root of 2 over 2. And it's going to give me the 45. Now, had my calculator been in radians, it would have given me the decimal value of pi over 4. Okay. Good, 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 good. Let's go ahead and take a look at this last one here, and then we'll move on to tangent inverse. So I want cosine inverse of 1/3. Okay, so it doesn't matter sine inverse, and you'll find it's not even going to matter when we get to tangent inverse. You always follow the same idea. Skylar, what quadrant will I be in? Will I be in the first or the second? Okay, second? First. Why first? Because 1/3 is what? 1/3 is positive. Had it been a negative 1/3, then I would be in the second quadrant. Okay. So positive puts me here in the first quadrant, just like before. Draw myself a right triangle with the x-axis. So again, I'm looking for that reference angle. Now, we said a second ago, cosine was the adjacent x over the hypotenuse r. So I'm going to put the 1 here. I'm going to put the 3 here. All right. Can anybody tell me what the height is? 2 root 2. Yes. Okay. Would anybody still like me to go ahead and write out the Pythagorean theorem to show where we got that? Okay. All right. What type of special right triangle is this? It's not. Well, how do we know it's not 45, 45? These two legs are not identical, so that throws 45, 45 off the table. Why couldn't it be a 30, 60, 90? Give me one reason. Raphael? There you go. He says the hypotenuse should always be exactly double the shorter leg, but 3 isn't double 1. Okay, so it's neither of those two triangles, so that means we're going to have to use what? We're going to have to use the protractor. We're going to measure it out. Okay, so let's get back over here. So let me go ahead and recreate this very quickly. Okay, so we had 1 here, we had 3 here. We were told this was 2 square roots of 2. Now, when I go to measure, I like to go ahead and use centimeters. You can use inches if you prefer. I think it'll just take up more space, but that is absolutely your choice. So the only thing is, I can measure 1 centimeter really easily, but I need 2 square root of 2 centimeters. How did we deal with this yesterday? How was I able to get exactly 2 square root of 2 centimeters? We converted it to something. Mm. Millimeters, right? So we were able to get a more exact value. So how do we do that? Let me go ahead and bring this up. So 2 square root of 2. So I need 2.8 centimeters. How do we convert that to millimeters? Yeah, what's that, Connor? Multiply by 10. 1 centimeter is 10 millimeters. And we probably don't even need to multiply. It's just going to move the decimal, but there you go. So I need to measure out about 28.3 millimeters. So that's going to give me a more exact space. So let's do that. Okay, so horizontally, I need 1 centimeter. Okay, so I measured 1 centimeter right there. I made a little mark. Okay. Now I'm going to go ahead and take this other one. Right at that mark, I'm going to go ahead, let's see. Every centimeter is 10 millimeters, so 10, 20, 28.3, maybe about right there. What do you guys think? Would you agree? Okay. Let me move this guy back out of the way. I'm going to draw my sides. Now, what I'm going to do when I draw my sides, I go ahead and draw them much longer than the sides of the triangle because I know I'm going to be trying to measure it on the protractor. Okay. There we go. All right. So remember, I'm looking for, this was 1 centimeter. Oh, I'll go ahead and write it. 10 millimeters. This was 28.3 millimeters. And I'm looking for this angle measure right there. Okay. So every protractor is going to have a crosshairs on it. I'm going to put that crosshairs directly on the origin of my graph. Okay, and let's see how well I did measuring this thing. There we go. All right. Looks like I'm off a little bit. For some reason, I'm always a little off on the class that I'm recording. Second period, nailed it perfectly. First period, got it nice. Of course, this one. All right, so what is my protractor saying? Now, I'm having to use my inside arc, so how far did I rotate? Looks like to me, about maybe 72, 73. Would you guys agree? Okay, so I'm going to go ahead and admit, mine's a little off. We're going to get the exact value in just a second, but what would you like me to put for an answer? Okay, well, 70 is going to turn out to be what we're looking for, but according to my measure, let's go ahead and say 72 degrees. Okay, because remember, I want to bring up a point. When you go ahead and do this on the test next week, what's going to happen? Is there going to be a leeway? There is going to be a leeway. Now, let's go ahead and see where Satish, did yours actually come up or did you try it in the calculator? Oh, you did, but perfect. If you were to go ahead and put it in the calculator, cosine inverse, it was 1 divided by 3. See, we're actually looking closer to 71, and I think I got 72, 73. So it's not horribly off, but I still die a little bit inside when I don't get it perfect. Okay. Anyways, would my answer that I put of 72 still work?
Yes.
Yes, that would still work out just fine. Now, did anybody get anything radically different than about 71 when they measured it? I think the furthest off anybody's gotten today, they got 65 degrees. Okay. All right. Good, good, good. Well, let me go ahead and get rid of this real quick. Yes. Now, if it's a special right triangle, you don't have to measure it.
No, 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 no. Like, there's an easier way of like the whole special right triangle. Like just looking at it.
Sometimes you can look at it. If you're very familiar with the unit circle, that's perfectly fine. Okay. But the reason I went ahead and did it this way is because I'm working pretty close with Mr. Heinrich, our calculus teacher, and this is how he does it. So for those of you who are going into calculus, the transition should be very nice because he uses the same strategies.
Okay.
Okay. Yeah, now if you have a different method, if you don't feel you need to create a triangle, I'm okay with that.
Well,
Okay.
it's not a triangle. It's just like
Oh.
if you divide by the radius, and it'll show the side.
Oh, yeah.
And it'll, yeah.
Yeah, that's fine.
Oh, okay, sweet.
Yeah, you're fine. All right. Let's go ahead and take a look at the inverse tangent. All right. So again, very similar to what we've done the past couple of days with inverse sine, inverse cosine. First, we want to go ahead and graph tangent. So let's not rewrite him in terms of sine and cosine like we did when we first graphed him. Let's just start with what we know. What's tangent's y-intercept? Aiden? I'm sorry, I'm old enough to pick up. Okay. So where does it cross the y-axis? That's what I'm asking.
Oh,
At 0, it crosses at the origin, right? Aiden, is that what you were saying? Oh, yeah, say it loud. Okay. So I'm going to go ahead and put 0, 0 right here. Now, tangent is the first graph we looked at to have asymptotes. So what's that consecutive pair of asymptotes we like to use for the compound inequality? What was it right about the origin? Okay, negative pi over 2 to pi over 2. So let's say this right here, this is negative pi over 2. This is pi over 2. Now, there were a couple of other points on the graph that we looked at because we wanted to get, 5 criticals. We also used pi over 4, 1, and then we used negative pi over 4, negative 1. Okay, so remember, tangent is going to look something like this. He curves up to the right. Now, this was just one period. He was going to repeat an infinite number of times. So I can put another asymptote right here, copy the point pattern, goes up, copy another one over here. Okay. Remember, that was the nice thing about the way we graphed these functions. Once you got one period, you just copied it as many times as you could. Okay. All right, so here's tangent. Now here's my question. Is it 1 to 1? If I put a horizontal line through here, am I touching it in more than one place at any time? In fact, I'm touching it in an infinite number of places because this graph just keeps going, right? So no, this is not 1 to 1. So just like we did with sine inverse, just like we did for cosine inverse, we want to restrict the domain. We want to shrink him down so that the horizontal line only touches it in one place. So we're going to do that by making one period. Okay, we're going to restrict the domain to one period. Now there's a typo here. This shouldn't be brackets, that should be parentheses. Okay. Because if you go back to the unit circle, at pi over 2 and negative pi over 2, tangent is undefined, so we can't include those. So we're going to say my domain is everything from negative pi over 2 to pi over 2. All right. So any extra part, I'm going to go ahead and cut off here. There we go. Cut off the other period. So I'm only going to have the graph exist between negative and positive pi over 2. What's his range? All reals. Yeah, he's infinitely tall, right? So I'm going to go ahead and say negative infinity to infinity. So now I want to take this information and I want to go ahead and graph tangent inverse. Okay. So what's going to happen to these vertical asymptotes? They're going to become horizontal asymptotes, yes. In fact, remember the very beginning of class, we said the big idea for inverses, we take the x's and the y's and we switch them. So when I'm looking for the domain and the range of the inverse, the domain of the inverse would be the range of the original. So this is negative to positive infinity, okay? And the range of the inverse would be the domain of the original, negative pi over 2 to pi over 2. Now, before I go ahead and graph this, take a look at those intervals for just a second. You know, once more, if you go back to the front page, you see that's exactly why we have those restrictions there. So I'm hoping now, you know, this is the third day. The first day when we started looking at this, we had no idea where those intervals came from, but I'm hoping now it's starting to make a little more sense. Why we have restrictions on what we can put in and what we can get out of an inverse function. Okay, so let's see here. I'm going to go ahead and say I'm going to use 2 units to go ahead and graph pi over 2 and negative pi over 2. And we can actually use the 3 points that we used on the original, just invert them. 0, 0 would still be 0, 0. But this point right here, which is pi over 4, 1, what would he be? He'd be 1 pi over 4. So if this is negative 1, 1, see, that's why I went ahead and chose 2 units. So pi over 4 would just be halfway between the two, vertically. The other ordered pair, negative pi over 4, negative 1, would be negative 1, negative pi over 4. So tangent inverse is going to look like this. In fact, it's going to look real similar to your cube root function. Okay, cube root, not cubic, sorry. Okay. And let's see if I can do this with any accuracy. If I were to take this graph that we just drew, place it on this one, you can start to see we have that symmetry. Remember, what's the line of symmetry for inverses? Remember, it was y equals x. Okay. Good, good, good. Now, let's go ahead and fill in these blanks. Again, I prefer to go ahead and write it as the intervals because your domain is all reals. And there are going to be textbooks, there will be some teachers who go ahead and write it like this. They'll use a compound inequality with an infinity. I don't personally like to do that because infinity isn't a specific number. You're just comparing an idea to nothing. Okay, but some people go ahead and do it. And there's also one other thing we need to change here when we go ahead and fill these in. The negative pi over 2 to pi over 2, those should be strictly less than. Okay. Remember, the range here, my answer, I can't include those boundaries. Now, sine inverse can, but tangent inverse can't. Right? So tangent inverse, as far as where my answers are going to come from, it's really similar to what other inverse function? Well, let's see. Let's look at the unit circle. Negative pi over 2 is right here. Pi over 2 is right here, so I'm only allowed my answers there. What quadrants am I looking at? 1 and 4. What other inverse trig function has the exact same location? Sine inverse, but there's one difference. What can sine inverse do that tangent inverse cannot? There you go. Sine inverse can include the boundaries. See, tangent inverse, we have to put a parentheses because he's undefined there. So while he is going to be in quadrants 1 and 2, we can't include those boundaries. We can go up to them, but we can't include them. Okay. So let's try some examples. Tangent inverse of 1. Okay. Now, like I said a few moments ago, doesn't matter if it's sine inverse, cosine inverse, tangent inverse, you always start the same way. You decide what quadrant you're going to be in. Both sine inverse and tangent inverse will belong to what 2 quadrants? 1 and 4. Cosine inverse, he belongs to 1 and 2. Well, how do I tell which quadrant I'm going to go in? Like for tangent inverse, how do I know if I'm going to draw it in 1 or 4? Yeah, 1 is positive, so that's going to put me where? Quadrant 1. Okay. All right, so just like we've done before, I'm going to draw a right triangle with the x-axis. So I'm looking for this measure right here, theta. Okay. Now, tangents ratio is always opposite over adjacent. It's always y over x, right? How would I make 1 into a fraction? Yeah, just 1 over 1. So my triangle here, I'm going to put 1 and 1. Okay. Now, can anybody tell me what would the hypotenuse be? Yeah, square root of 2. 1 squared plus 1 squared, and then we take the square root of that. Okay. Now, is this one of my special right triangles? Yes. In fact, which one? 45, 45. What immediately jumps out and tells me that? Yeah, the fact that these two legs are identical. So I know this is 45, and I know that's 45. So theta here is 45 degrees, or what would that be as a radian? Pi over 4. Okay. All right, now we may not finish B, but we'll at least go ahead and get started with it. What I'd like you to do, you still don't have any homework. Take a look at D. Okay, try to figure out D before you come back into class tomorrow, because we'll just go ahead and pick up where we left off. We might just be able to get the triangle here on B. All right, so who haven't I talked to today? How about Rhett? I want to evaluate tangent inverse of negative square root of 3. What quadrant would this put me in? 4, because it's negative. Okay, so I'm going to draw my terminal side. Okay, I chose 4 because this one's negative. I'm always going to connect it to the x-axis. That's how we get a right triangle. And the only thing is, because this is in quadrant 4, I am guaranteed my answer should be what? Negative. We always start rotating from standard position, and if we're in quadrant 4, it has to be negative. Okay? So let's see here. Just like before, how can I change negative square root of 3 into a fraction? Put it over 1, right? And we know tangent is the opposite over the adjacent. So this would be square root of 3. This would be 1. Square root of 3 would take the negative. And what's my hypotenuse? It is 2. Okay. Is this a special right triangle? Yes. But what is that angle we need? Is that 60 or is that 30? 60. So my answer is either going to be a negative 60. Remember, in quadrant 4, it's got to be negative. Or what's the radian measure? Negative pi over 3. Is this starting to make sense? All right. Thank you guys very much. Don't forget your cell phones. If you have one of my protractors, please put it back in the box. You guys have a great day. I will see you tomorrow. Don't forget your cell phones.